Hello everyone, welcome back to my channel. So today we are in general organic chemistry. In that general organic chemistry today now I am going to explain about the what is the inductive effect, what is the resonance effect, and as well as what is the hyperconjugation. And if you see, I hear that many people are saying organic chemistry is a very tough. Organic chemistry, it is very tough. Obviously, organic chemistry is a very tough until unless you know the basics, my dear friends. If you know the basics, then you know how you are playing the games, right? You should play the organic chemistry like a games, my dear friends. When you know the this organic chemistry. So let me ask a simple question: how many people are facing this problem? How many people are facing this problem? When next day you are in exam, before the exam you practiced many times of any synthesis. You take any synthesis. We are going to practice 5 times, or we are going to practice 10 times. While writing the exam, that question, in between the question, while writing the answer, in between the answer, so which bond will here will use, whether they are using double bond or single bond, which reagent they are using, whether oxidizing agent or reagent, reducing agent, which acid they are using, whether acid or base. So at that time we are going to confuse while writing the examinations, my dear friends, because we are by heading the chemistry, we are not understand the chemistry, which reagent is using, whether oxidizing agent or reducing agent, or whether acid or base, which reagent they are using. We are not going to understand the reaction. We had simply by heading the chemistry, my dear friends. That is the reason only we are assuming that okay, organic chemistry is a very tough while learning this organic chemistry. So if you know the this basics of this organic chemistry, it is very simple. You can easily understand this organic chemistry. Today now I am going to explain about the basics of this organic chemistry. So come to the point. So here today we are in inductive effect as well as resonance effect as well as hyperconjugation. So I will give short and sweet of this chemistry. Inductive effect as well as resonance effect and mesomeric effect. See here, inductive effect. What is that inductive effect? Let us I will give the examples to you so that you can understand. Here carbon, 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 and here X. So these are all considered as a hydrogens. So when X is nothing but it is the electronegativity atoms like NO2 or CN or any fluorine, more electronegativity atoms. So this more electronegativity atom, here we have a covalent bond, right? So this covalent bond, more electronegativity atom, it is going to pull the electrons towards the more electronegativity atom. Then you can get partially negative charge. So when it is going to pull the electrons towards the more electronegativity atom, then you can get positive charge, right? So here it is going to get some partial positive charge. Here you will get some partial positive charge. It is negligible. So this is for what mainly concept of this inductive effect. It is a more electronegativity atom. This more electronegativity atom pulls the electrons towards the more electronegativity atom. This is called minus I effect. So when it is donate the electrons towards the more electronegativity atom, these are all comes under the plus I effect. This is for what minus I and plus I effect. This is called inductive effect, my dear friends. Very simple. I will give one more examples to you. CH3, CH and CH double bond CH2. Which one is minus I effect? Which one is plus I effect, my dear friends? You can consider these are all comes under A. These are all comes under B. So which one is plus I, which one is minus I? You can take here this carbon, it is having a sp3 hybridization. So here you take this carbon having a sp2 hybridization. I think you know that if S character is increases, electronegativity increases. So you will get here minus I, here it is a plus I, right? I hope you understand. I will give one more example so that you can understand what is that exactly this inductive effect. So here you take one more example. I will take, so it is right. So which one is, you will take, this is one is A, this one is B. So which one is minus I effect, which one is plus I effect? If you see, here we have a oxygen, right? Here you have a carbon and oxygen. Which one is more electronegativity atom? Obviously oxygen is more electronegativity atom, so it is a acts as a minus I effect, it is acts as a plus I effect. This is our what inductive effect. And coming to the resonance effect, every compound needs the stability, right? So if it is more resonance, if it is a compound containing a resonance, then it will get the more stability. If you see the resonance effect, so if the compound containing a more resonance, that compound is more stability. So if we take, I will take one examples of in this resonance. Best example, so here you take one phenol, right? So it is going to resonance, it is going to resonance. See, this lone pair of electrons is migrated towards this place, and this bond is migrated towards this carbon. Then you will get here, right, oxygen containing positive charge. So you here you will get negative charge. Am I right? So again, this bond is migrated here, this bond is migrated here. So you will get here you will get OH positive charge, here you will get negative charge. So again, this bond is migrated here, this bond is migrated here. So what you will get, so here you will get double bond, and here you will get, so here you will not get double bond, here you will get negative charge, right? Here you will get negative charge, here, and after that if you see, this bond is migrated here, this bond is migrated here. Finally you will get the compound is OH. Again you are going to get phenol. So if you'll get, this is for what? Resonance effect. So this phenol is more stability because this is resonance effect, right? So as well as coming to the hyperconjugations, what does that hyperconjugations? It is also acts as a more stability. In that hyperconjugations, I will give the example so that you can understand what is that hyperconjugation. If you see hyperconjugation, so here you have a hydrogen, carbon, hydrogen, hydrogen. Here you have a one positive charge. So here we have a one empty d orbital, right? So see this bond is migrated here. So what we will get once if this bond is migrated here? So see here, you will get here negative charge, here oxygen containing a positive charge, hydrogen, hydrogen, here CH2 positive charge. So this negative and this positive, it's going to form a bond. Obviously you will get the bond here, C double bond CH2 H H. So here you will get the stability. This is called what? Hyperconjugations. Hyperconjugations also, it is going to needs the stability of this compound. So if you see, this is for what? This is the you can place H, place H is nothing but place H hyperconjugation, as well as minus H or minus H conjugations. What does that mean? Minus H conjugation, it's very simple. Instead of, you can take chlorine, 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 here you will get CH2, you will get positive charge. So if you are going to treat it with this, chlorine will leave, then you can get, you will get here negative charge. So once Cl, you will get positive charge. Here you have a one negative charge. This negative and positive, you will get double bond, right? Cl, C double bond, CH2. This is for what? Hyperconjugations. It's very simple. I will give the just short and sweet examples of this inductive effect, as well as resonance effect, as well as hyperconjugation. I hope you understand these reactions. Thanks for watching, everyone. Thank you so much for watching this video.